Okay, 3.2. Consider one potential recipient and two different emission sources, X and Y. And again, we've got a couple of cost functions. We're going to talk about these cost functions, by the way, because I'm not too happy with them. But we've got a couple of cost functions for abatement. And again, we've got an environmental target, but this time there's no uncertainty. And part A says, determine the cost-effective abatement level for the two emission sources. So, let's set this up this time in terms of the costs rather than the profits. So let's say that C is the total social cost of meeting the target, which is 50 AX plus 2 AX squared plus 100 AY plus 3 AY squared. Okay, and then we've got this target, which is the restriction. So let's set it up as a Lagrangian instead. So instead of minimizing costs, we're just saying, look, we've got this Lagrangian, and we're going to look at the necessary condition. So then we have minus lambda times the restriction, which is half AX plus AY minus 30. So again, you're always going to meet the restriction with equality in this kind of case, because you've only got costs of meeting the restriction. You're never going to abate too much. So we can just write it like this and not worry about any risk that lambda might be 0. Okay. So we're getting a lot of practice at just setting up and solving Lagrangians here. So you should get really used to this. So this one is super straightforward. So we can do the first order condition in AX. What do we get then? 50 plus, 50 plus 4AX equals lambda on 2. And why don't I can already tell the other one is going to have a term in lambda. I'm going to want to get rid of lambda. So why don't I multiply this through by 2? And say 100 plus 8AX equals lambda. I hope I got that right, yeah. And then in AY, we have 100 plus 6AY equals lambda. Let's get rid of lambda. This equals this. So it's super straightforward. 8AX equals 6AY. And what next? Well, we need to use the restriction, don't we? So this is one equation, but we also know that AX plus 2AY equals 60. So I've multiplied it by 2. But actually, if we want to get rid of AX or AY, we should multiply it by another 3, shouldn't we? 3AX plus 6AY is 180. So then if we take 8AX plus 180, no, minus 180 must be equal to 6ay minus this lot. Equals 6ay minus 3ax plus 6ay. Yeah, and why did I do that? To get rid of the ays. So then we've got 11ax equals 180. Ax is 180 divided by 11. Let me just check. Yep, so that's looking good. I just checked my crib sheet. And ay is 8 divided by 6 times ax. So that's 4 divided by 3 times ax. So ay, divide this by 3, you get 60 times 4 is 240. So that's 240 over 11. It's ay. And I'm going to pause again. Okay. Part B, find cost-effective charges and the trading ratio under a permit market. Okay, find cost-effective charges and the trading ratio under a permit market system. Okay. So we could sort of go back to square one here, set up the firm's problem with a charge, and work out what the firm emits, or how much the firm abates as a function of the charge, and then find the charge to give this level of abatement. Or we could just do a bit more thinking and say, look, lambda here is the shadow cost of emissions by firm Y, the way we've set this up. And we know that the charge on firm Y should be equal to the shadow cost of emissions by that firm from theory. So the charge or the tax on firm Y should be equal to lambda. And what is lambda? It is 100 plus 6ay, which comes out to, 100 plus 6 times 240 over 11. It's pretty straightforward. We're going to end up with torr Y is 230 and 10/11. And again, just from theory, we know that the charge on firm X is going to be half of that, because only half of the abatement by firm X actually has any effect on the recipient. So torr X is 115 and 5/11. As I said, if you want to, you could set up the firm's problems as a function of an unknown tax, torr Y and then torr X for the two different firms, solve them, and then find the tax rate that gives these abatement levels. And you would get the same answer, at least if you did the math right. We're also asked about the trading ratio in a permit market system. I guess what this is about is that if you're going to have an efficient market system, if you can't just have a permit for emissions, can you? It's not going to be perfectly efficient, because emissions by Y are worse than emissions by X. So if the permits are sort of for X emissions by X, if one permit gives X the right to emit 1 unit, then the same permit should only give Y the right to emit half a unit. I guess this is just a theoretical construct. I have a hard time believing that there are any permit systems where this kind of thing is actually applied. But you can gladly disprove me. Okie doke. I've done a bit of rubbing off, and we're now going to look at 3.2c, where instead of the target, we can wipe this target. We've got a benefit maximization problem. So now, instead of just trying to reach a sort of arbitrary target, so to speak, we're actually going to try to maximize benefits, because we're assuming that we know the damage function or the benefit function from abatement. And the benefits of abatement are as follows, and this is pretty weird, but whatever. So total benefits are the benefits from abatement, which is 160 AX plus 190 AY minus 5.4 AX plus 0.7 AY squared. That's benefits, and then if we're looking at net benefits for society, we then need to subtract the costs. So this is super straightforward. Okay, once you got the hang of these things, this is just so straightforward. So it's just the two first order conditions, isn't it? So the first order condition in AX gives us 160, and then how do we do this? Remember, I didn't talk so much about this, but we differentiate the outside, and then we go inside and we multiply the two. So it's minus 5 times 2 times what's inside. So that's minus 10 times 0.4 AX plus 0.7 AY. Then we go inside and multiply by 0.4. And then we've got minus 50 minus 4 AX equals naught. So let's put the equal sign here, and now we've got plus signs everywhere. Why don't we simplify this a bit before we go any further? So 160 is 10 times 0.4 is 4 times this. So that's 1.6 AX plus 2.8 AY plus 50, we'll take that over and have 10, 110 instead, plus 4 AX, so that's 5.6 AX. Okay, I hope that turned out right. In an exam or whatever, you should be being a bit more careful. First order condition in AY, 190 equals, I'm going to go straight there, 10 times this times 0.7, so that's 7 times 0.4 AX plus 0.7 AY 100 plus 6ay. And I've got plus signs because originally they were minus equals 0, I've shifted them over. So again, let's simplify right away. So we've got 90 equals 2.8 ax plus 4.9 ay, 10.9 ay. And I'm just going to pause and take stock here. Okay, so I just had a look at this, and we've got 5.6 ax here and 2.8 here. So why don't we multiply this by 2? So we're going to have 21.8, and then we take this and subtract this, and we have 70 equals 21.8 minus 2.8, 19 ay. Ay is 70 over 19. And I'm not going to go through ax. I don't know if we can get an expression like this or not, but in my crib sheet I've got that ax is 17.80. Okie doke, another brief pause. Okay, so finally, part D, there's more work to do. So this was fine for part C, which asked us to find the efficient levels of abatement for the sources. But part D says we need taxes for the sources. So how do we do that? We've got to go and set up the firm's problems. Okay, but this is great practice actually. I mean, the algebra is a bit tedious, but it's great practice at setting up these problems, getting your head around how to set up these kind of optimization problems. So, let's put ourselves in the shoes of the regulator who's thinking, what tax should I put on these firms? Well, the regulator wants the firms to abate in this way, so the regulator has to ask herself, what tax do I need to make the firms abate in this way? And to answer that question, the regulator needs to set up the firm's problems, including tax payments. So, what are the firm's problems? So, the costs for firm X, the total costs, if you like, including the tax, are 50 ax plus 2 ax squared plus the tax on x times a naught x baseline emissions by x minus ax, which is abatement by x, isn't it? So as usual, I mean, it would be much nicer if these problems were set up in terms of emissions rather than abatement. But whatever. So then what's the firm going to do? We just take the firm's first order condition in AX to work out what the firm is going to do as a function of tau x. So the firm is going to make sure that 50 plus 4ax minus tau x equals 0. Ooh. Okay, so tau x should be equal to 17.8 times 4. What is that? 70 to 71.4 plus 50 is 121.4. Okay. check my crib sheet. Okay, yeah, I got 121.2. Yeah, it's 70.2. 70.2, 121.2. And we could easily, the same process for firm Y, what would we have then? We'd have 100 AY plus 3 AY squared plus tau Y, AY naught minus AY, first order condition, blah blah blah. You should end up with tau Y ends up more or less identical. And I don't think you're asked to comment on that because it's, yeah, it just happens to turn out that way. Okay, that's the end of question 3.2.